All right, so in this video, I wanted to just briefly kind of show you writing files with Pandas. So a lot of times with Pandas, what we're doing is we've got some data, we bring it in, we do some type of data cleaning, and maybe it could be that that actually takes quite a while, right? So maybe you're reading in large data frames, you're doing joins, you're doing a lot of different processing. And then you would rather save that file, that clean data, so that you can use it later, rather than just having to repeat that every time that you need to touch that data. So in addition to being able to read data and work with data, we also want to be able to persist or save data so that we can use it. And I'm going to show you, I mean, of course, just like we saw with reading in our input video, there's a lot of different ways that we can write data as well. All right. So I'm back with this store sales forecasting data. I'm just going to read this in real quick, and then we've got our data, and let me just do the head. All right. So we've got, this data, and if I were to look at our D types, right, we've got all of these columns. So let's say that we had brought it in, we've done a lot of cleaning, but one thing I am going to do as far as kind of working with this data is I'm going to go ahead and convert those order date and ship date columns into date times, because this will be really relevant for this example. So I'm just going to say order date, and we saw this in our working with date values video. I'll do a pd.to date time, and I'm going to take the value in that column. And I'm going to do the same thing with ship date. All right. Very good. All right. So now if I do data.dtypes. All right. So we've got these date time columns. Now, again, you could have done a lot of different other types of cleaning and whatnot on this and really have data that looks a lot different than it did when you ingested it, which in our case, the column names are quite different. So if I were to go and actually try to find that raw file, so if I look at this sales, store sales forecasting CSV, you can see that the original column names were, let's see if I can zoom that in. Yeah, so like order ID, it was capitalized letters with spaces, and we did that column cleaning. So let's say that we've done our column standardization, which we, let's see, don't say, which we have done. We've done our standardization here. Now we've done some date time conversion. All right, so we've got data. And when we saw Pandas has like a pd.read CSV, but if you have a data frame or a series, you also have a dot. You've got a bunch of methods that start with to. All right, so this is how you write data. So I can say, we'll send this to a CSV file. All right, so if we did this, you can give it a file name. So I'm going to say this is going to be my clean data .csv. All right, so notice we've got our data with our clean column names, and our indexes are still there. If we do a data.toCSV, and then I go, look, now we have my clean data. If I were to open that up, notice now that we've got our data with our nice clean column names. One thing that I tend not to really like that Pandas does by default is notice it put an extra column out here. Well, what is this column? Well, this is your index labels. So there's your column labels, and it goes ahead and it writes your index labels as well by default. All right, so how do we get it to not do that? Well, let's look at our arguments, right? As we've seen, these Pandas methods have a lot of different arguments, right? So notice it's got this argument called index, right? And its default is set to true. So what you can do is you can say index equals false. And now when you do that save, right, we don't have our index, right? So we got our nice clean column labels here. We did do a date conversion, right? This looks a little bit interesting. We'll talk about this in a minute, but we don't have those index labels. So I usually will set that index equal to false. I don't want to create that column. It's kind of odd. And then sometimes when you read it in, it looks really odd. Let's actually show that. So what happens if we keep our index there? All right, let's say that we write that to a CSV, And then later on, I'm going to load in our new data. I'm going to say pd.read CSV. And let's read in the file we just saved as my clean CSV. All right. Nice. So that reads it in. Notice what it does to this. It creates this new unnamed 0, right? Well, that wasn't our original data, so everything else looks good, right? We've got our column names. That standardization is in place, but now we got this new column called unnamed 0. Well, where did that come from? Well, if I go back and look at my clean data, well, when we write it and we don't specify not to include the index, it puts that index in an unnamed column. So when Pandas reads this, it says, well, you didn't give me a name for the column. So I've got these values out here and I'm just going to create an unnamed column and read that thing in. So you get this odd column name that then you got to go back and rename again or whatnot. So what if we had just saved that data without the index? So we can say index is equal to false when we write the file. All right, we've rewrote it. Now when we read it in, we don't get that. All right. Now there's another thing that I want to show you. So remember originally, right, when we wrote data, right, if I do data.dtypes, those order date and ship date were date times. All right. Let's look at what happens in new data. So if I go to new data and do dtypes, there's strings again. So it did not preserve our date times. So if we thought that those things were date times and we read it in and we try to do date time operations on it, it's going to fail. Because when we write things out to a CSV file and we read it back in, we're losing that information. It's because, you know, CSV files are just storing it as text on disk, right? I think it maybe text and numeric values that it's storing with strings or commas separating it. So, you know, a CSV format has no concept of a date time. So when we write it to a CSV, what Pandas is having to do is say, well, it's a date time, but I'm going to convert it to a string representation so that I can actually save it as a CSV format. And when you read it back in, you're stuck with strings. Well, can we get around that? We can. So I'm going to restart my kernel just to clean everything up. I've been kind of going around. I'm going to import. I'm going to do this conversion. And we've got our data types here, so date times. What I would suggest you at least try to do, so whenever I'm creating new environments, one thing I like to install is PyArrow. All right, so what is Arrow? Let me see if I can open up a new incognito window. So Arrow columnar. All right, so Arrow is a columnar data format that's under the Apache Arrow project. And it defines this specification for a particular type of formatting that is really efficient to store, really efficient to read. And as we're going to see, it can store some data about the data types, which is really, really helpful. A lot of your new DataFrame libraries, such as a polars, are kind of built around this specification. And again, it's going to make, you know, things easier to save on disk. And as we're going to see in a minute, things can read really quick, and it's going to preserve our types. All right. So the file format that we can write that uses that PyArrow columnar format is we can use a Parquet file. All right, so one thing I'm going to show you right now on disk, when we wrote that my clean data CSV, that's about 500 kilobytes, nothing big, but that's our reference. When we wrote this data out using a CSV file, we had 500 kilobyte file. Well, if we do data, and now if I do to underscore, instead of a CSV, what if we did a Parquet? All right, so we pass it a path. We again can specify this index. Let's just make sure it works the same way. So if it's true, it includes the DataFrame's index. If it's false, it's not written. If it's none, it's similar to true. So we want to specify this to be false because the default is none. So we had called it mycleandata.csv. Let's make a Parquet version. mycleandata.parquet. And I'm going to say index is equal to false. All right. Takes it a second there, but we should see that we've got this Parquet format that's come up. Let's look at that on disk. All right, so first off, notice the size. So my clean data CSV is 500 kilobytes. Our Parquet file is a lot smaller, so it's 140, so it's smaller on disk. One thing that is a challenge about Parquet, with a CSV, you can open it, right? So you can use Excel or whatever your spreadsheet software is. So I've got LibreOffice on this machine, so you can use that to open it. You can't do that with Parquet files, right? So they're a binary format that you can't just load in, whereas CSV is like, it's a text format that can be parsed by something like Excel or LibreOffice. So if I double click this, it's going to say, hey, I don't know what you're doing. I don't know how to do this. Now, I'm sure there's probably applications out there that will allow you just to render, double click, and open a Parquet, but I don't have one on my machine right now, and definitely it is a less common format. But we can see that it's significantly lower disk space usage, right? So 140 versus 500. Let's see what happens when we read it. So remember when we wrote this, right? So data.dtypes, those two columns were date times, right? Which when we wrote it to CSV, we lost that information. So now let's do a read. Instead of a CSV, we can do a read, not a data.read. We'll have to do a pd.read Parquet. And that's going to be my clean data.parquet. And I'll say this is going to be my new data. All right, so that reads. Everything looks great, right? So no real glaring differences at this point from what we read the CSV, but let's look at the D types. It preserves that information, right? So again, Parquets have a lot of advantages, right? In the sense of usually they're smaller on disk, and because of that, they're easier to read. And a really nice thing is if you do some kind of date type or data type conversions in your cleaning code, especially to, I guess, non-typical, right? So instead of just integers, floats, and strings, if you're using things like date times, it will preserve those data types much more closely to what you defined. Right, so I can't say that it's going to be perfect in all cases, but like in this case, you could really put a lot of effort into getting things in the appropriate date time format. So you don't want to lose that when you write your file, right? Because then you got to repeat that processing every time you load it. If you can use a file format that just persists that, you're gonna reduce those opportunities for errors as you got to rewrite that code to deal with it, and just speed things up so much more. All right, so that's a little bit about writing data using Pandas, so you can do your processing and then use a to method to do that. There's a lot of to methods, right? Just like there are a lot of read methods. So if I do a pd.to, or it's going to be a data. So I've got data. I'm trying to write a data file. So data to, sorry. Yeah, there's a lot of different things that you can do. So JSON, Markdown, NumPy, Parquet, CSV, Excel. I think you can even do SQL to write directly to database. So a lot of methods there. Of course, each one of them is going to have their different behaviors, different parameters that you can set. Depending on your use case, there's going to be certain ones that you use. If you're always writing to databases, probably really investing the time to learn the toSQL method is going to be helpful. If you're working with files on disk, like that's a lot of times what I do, I'm usually writing things to Parquet files and then passing those around. All right, so hopefully that was helpful, and that will conclude this video on writing Pandas data.